Hello everyone, welcome to another video of Advanced Mathematics of Class 8, and this time we are starting chapter 6, that is similar geometric figures. So we'll look into the first theorem of this chapter, which is the basic proportionality theorem. Now what does this theorem state? The line drawn parallel to a side of a triangle divides the other two sides of the triangle in the same proportion. Now what does this mean? Let's look at it with the help of a diagram. So suppose we have a triangle here. So let the triangle's name be ABC. Okay, suppose ABC is a triangle, and now if we draw a line segment, suppose we draw a line segment here, and this line segment, which is named as PQ, should be parallel to BC. So if PQ is parallel to BC, if this is the condition, okay, if this condition is fulfilled, that means it is satisfied. So if PQ is parallel to BC, in that case what happens? It divides the other two sides of the triangle in the same proportion. That means the ratio of AP to PB, that means AP by PB, will be equal to the ratio of AQ by QC. AQ by QC. This is what the BPT or the basic proportionality theorem states, that if one line is parallel to the other line of a triangle, in that case this line PQ will divide these two sides AB and AC in the same ratio. That means they will be in proportion. So AP is to PB, or AP by PB will be equal to AQ by QC. I hope that is clear. It is a very simple theorem, and this theorem I want you people to know it nicely, understand it properly, because this is going to be useful in our future classes also. In class 9 and 10 this is going to be very useful. So don't overlook this theorem. If you have not understood, go back again in the video, go back in the timeline and watch the theorem again, what I have said. Okay, you will understand. Repeat. If you don't understand, repeat it over and over again, because this is a very important theorem. So once we understand this theorem, we can apply this theorem in our exercise. So now we will move into our next exercise. Okay, the first exercise, exercise 6.1. So welcome back to our next segment. That is, we have started the exercise 6A, and the first question states that this is a triangle where PQ is parallel to BC. So if PQ is parallel to BC in triangle ABC, these values are given. That AP is equal to 6 cm, PB is 8 cm, AQ is 9 cm, then what will be the value of QC? We have to find what is QC. So see, we will be using this theorem here, the theorem that we have studied, the basic proportionality theorem in this sum. So since PQ is parallel to BC, we will write since PQ is parallel to BC, therefore by basic proportionality theorem, what will we have? According to our theorem, we will have that AP by PB is equal to AQ by QC, right? So we will have AP by PB equal to AQ by QC, which implies we know the value of AP. AP is given as 6 cm, PB is 8 cm, AQ is 9 cm. We just need to find QC. So by simple linear equation solving, we can find the value of QC. So how do we do it? Let's solve it here. So 2 threes are and 2 fours are. So thrice QC, side change, QC is divide here. When you side change QC, it becomes multiplied to 3, and we will have 9 into 4. So which implies QC is equal to 9 into 4 by 3. 3 threes are 9 and 3 fours are 12. So therefore QC is equal to 12 centimeter. So this part is now 12 centimeter. Okay, hope you understood. This is the first sum of 6A. Let's move on to the next one. Let's move on to the next one, which is question number 6. And what do we have here? Let's look at the question. The diagram is this. So here it is given that AB is parallel to PQ. So here this AB is parallel to the PQ line, and BC is parallel to Q1. So BC is parallel to Q1. So what do we have to do here? We have to prove that, or we have to show that AC is also parallel to PQ. So So you have to show that this AC line is parallel to the PR line. Okay. So AB parallel to PQ, BC parallel to QR, we have to prove AC parallel to PR. Very simple sum. We will just be using this basic proportionality theorem and we will be solving this sum. Okay. So let's go. First of all, what we will do, we will select a triangle. Now, which triangle are we selecting? So from triangle OPQ, this one, okay, OPQ, this big triangle on the left hand side. We will be choosing this triangle on the left hand side. Just look at this one, don't look at the right hand side part. So look at OP and Q, okay, OPQ, this triangle, okay. So from triangle OPQ, what do we have? It is given that AB is parallel to PQ. So in this triangle OPQ, AB is parallel to PQ. AB is parallel to PQ. So therefore, by basic proportionality theorem, what do we get? Since AB and PQ are parallel, therefore OA by AP will be equal to OB by BQ. Is it clear? Think of this triangle. Forget about the other lines, okay? See OP, PQ and BO. These are the three sides of the triangle. Here AB is parallel to PQ. As a result, what will happen is OA will be parallel, OA to AP, the ratio will be equal to AB, OB to BQ. So let us write this down. We will have OA by AP equal to OB by BQ and take it as our equation number 1. Similarly, we will do it on the right side triangle, that is ORQ. From triangle ORQ, here BC is parallel to QR. It is given in the question. BC is parallel to QR. So what will happen? If BC is parallel to QR, then OB by BQ will be equal to OC by OR. Using the same theorem, we will have, by basic proportionality theorem, we will have OB by BQ is equal to OC by CR, number 2. Okay, so this is what we have got from the two given data, that OA by AP is equal to OB by BQ, and here OB by BQ is equal to OC by CR. Now look into the two equations. In both the cases, OB by BQ is common. As a result, what will happen? Since this is equal to OB by BQ and this is also equal to OB by BQ, that means these two must be equal. So from 1 and 2, what do we get? OA by AP is equal to OC by CR. Now look into the diagram again. If OA by AP is equal to OC by CR, okay, OA by AP is equal to OC by CR, then in this triangle, in this big triangle, what do we have? AC and PQ must be parallel. It is the reverse of our BPT. BPT says that if two lines are parallel, then OA by AP will be equal to OC by OR. Now that we have here OA by AP equal to OC by OR, that means if this ratio is equal, that means AC and PR must be parallel. So therefore AC will be parallel to PR, hence proved. Okay, so this is about question number 6. I hope you have understood. Let's move into the last one. Let's move into the last sum of the day, and here we have this diagram, and what you can see, PQR is a triangle and we have three lines, LS, QN and MT. So what is given here? L is the midpoint of PQ, M is the midpoint of QR and N is the midpoint of PR. These are the three data given. Along with it is given that LS is parallel to QN and MT is also parallel to QN. Using this, we have to prove that PS equal to SN equal to NT equal to TR. Means PS, SN, NT, TR in this diagram, all these four segments are equal. This is what we have to prove. So how do we do this? Another simple sum. So let's see what to do. Look, first of all, since L is the midpoint of PQ, that means this part PL and LQ, this must be same, this must be equal, since L is the midpoint. In the same way, since M is the midpoint of QR, so QM and MR, these two should also be equal, right? Let us write this down. So since L is the midpoint of PQ, therefore PL will be equal to LQ, number 1. Since M is the midpoint of QR, therefore QM must be equal to MR, number 2. Now let's move into our theorem, that is BPT, Basic Proportionality Theorem. So what do we have here? It is also given that LS is parallel to QN. So let us select the triangle PQN, okay, this one on the top side. PQN, in this triangle we have LS parallel to QN. So if LS and QN are parallel, in this case PL by LQ will be equal to PS by SN according to our theorem, right? So from triangle PQN, LS is parallel to QN, therefore by basic proportionality theorem, what do we have? As I have said, PL by LQ will be equal to PN by PS by SN. So we will have PL by LQ equal to PS by SN. Now look into number 1. PL and LQ are equal, right? So what we can do here, since PL and LQ are equal, we can replace them. So in place of PL we can write LQ because these two are same, by LQ equal to PS by SN. So LQ will cancel. So now if we do side change, we will get PS into 1, that is PS, and SN into 1, that is SN. So from the proof part, we have proved one thing, PS equal to SN, this one we have proved. Let's take it as number 3. We will do the same thing, but this time for this triangle Q and R, okay? In Q and R, it is given that MT is parallel to QN. So since MT is parallel to QN, therefore RM by MQ will be equal to RT by TN, right? RM by MQ will be equal to RT by TN. Look at this triangle. Okay, in this triangle, these two sides are parallel. So therefore, RM by MQ equal to RT by TN. This is what we are going to write here. That from triangle RQN, MT is parallel to QN. Therefore, by basic proportionality theorem, by basic proportionality theorem, we will get from here RM by MQ is equal to RT by TN. Okay, now RM means MR, same thing, and MQ means QM, same thing. This is TR and this is NT, obviously. Now here we have seen that QM and MR, these two are equal. So here in place of MR and QM, we can replace them. So we can write QM by QM equal to TR by NT. So these two will cancel. Again by side change, we can get TR is equal to NT. This is number 4. Okay, so we have got two things. So here also we have got NT and TR are equal. So we have proved PS equal to SN, this part we have proved. And we have also proved NT equal to TR. But this set is proven, this set has been proven. But this connection we need to make. Once we can make this connection, the whole thing will be done. So how to make this connection? Now, here it is said that N is the midpoint of PR. So since N is the midpoint of PR, therefore PN will be equal to NR. Of course, these two parts, this PN will be equal to the part NR. since n is the midpoint. Now Pn will be equal to Ps plus Sn. Ps and Sn, if you add them up, you will get Pn. So Ps plus Sn. In Nr also we can write Nt plus Tr in the same way. Now again, here we have proven that Ps and Sn are equal. So in case of Ps, we can write Sn plus Sn. And here we have proven Tr and Nt are equal. So Nt, and in case of Tr also we can write Nt. So these things we have taken from number 3 and number 4. So this is twice of Sn equal to twice of Nt. So 2 will cancel out and we will get Sn equal to Nt, which is our number 5. Now let's look into the 3 equations that we have got. One is Ps equal to Sn, one is Tr equal to Nt, and one is equal to Sn equal to Nt. So Ps and Sn are equal, Sn and Nt are equal, and Nt and Tr are equal. That means all these are equal. Ps equal to Sn, here we have got Sn equal to Nt, so here we have Sn equal to Nt, and here we have got Nt equal to Tr. That means here also Nt equal to Tr. So from all the 3 equations, from number 3, number 4 and number 5, we have Ps equal to Sn equal to Nt equal to Tr. Hence we have shown the required proof. So this is the overview of the whole sum. I hope you have understood what we have done here. If you have any questions, then make sure you ask me in the comment section down there, and you can bring it up in the class as well. So thank you everyone for watching. Until next time, cheers.